if you came through here, right, you grabbed all the handouts. And so we're going to start with question 2 here, since 1 is already done. If not, I posted this handout yesterday, so you can go get it there. A ladder leaning against the wall makes an angle of 74 degrees with the ground. If the foot of the ladder is 6.5 feet from the wall, how high on the wall is the ladder? Right, so we have our ladder, we have the ground, we have the wall. The wall could be taller, mind you, but it's saying, you know, it's reaching up. Like if you take the top of that and measure it from the ground. Who's saying what here? Or did somebody have their hand up? Oh. Okay, noted. So we have this is what they're asking us for. How high up the wall is the ladder leaning against the wall? The 74-degree angle is made between the ladder and the ground. And it's the foot of the ladder is 6.5 feet from the wall. So this is where the 6.5 goes. So the hypotenuse is completely unknown, and we don't care about it. So based on this, you label opposite. This would be your hypotenuse. You don't care about it. You do care about the adjacent, right? This is just a regular finding the side. So O and A, right? That should remind you of TOA, right? So tan of 74 degrees is equal to opposite, which is x, over adjacent, like that. You put the 1 there, so you're going to cross multiply and divide. So x is 6.5 times tan of 74 degrees. Grab my calculator here. 6.5 times. Always check, is my calculator set to degrees? Because sometimes if you put it in your backpack or whatever, it changes the settings, right? So 22.668, so that will be 67 feet. Final answer is always to 2 decimals for us, okay? I'll do the attendance in a bit. Okay, got you, Ty. Thanks for letting me know, though, because sometimes I do it right away. Now I want to get going so I can give you the AC, and then once you're writing the AC, I will do the attendance there. Question 3. A straight road to the top of a hill is 2,500 feet long and makes an angle of 12 degrees with the horizontal. I need you to remember that. Horizontal, think of the horizon, right? The sun, if this is the sun, right? The sun sets on the horizon, right? So horizontal is always sideways. Vertical, right? This would be vertical. This is horizontal. Okay, so keep that in mind. A lot of students forget that. So we're talking about the road going to the top of a hill. So this is the road, and we know that the road is 2,500 feet. We know that there's the ground, like level, and this is the height of the hill, right? And so, okay, Gurjat, yeah, I'll do the attendance in a bit. So in a sense, right, like this hill goes like up and then goes down like that, right? So you almost have to imagine, of course, the hill is kind of, it's never perfectly straight, but they tell you that the road is straight. And that's 2,500 feet. It says that it makes an angle of 12 degrees with the horizontal. in this case, the horizontal is our ground, okay? So the 12 degrees goes there. It says find the height of the hill. So this would be the height of the hill. So based on this angle over here, this would be the opposite. This would be our hypotenuse. And there we go. So O and H, that's so, right? That helps you set it up. Sine of 12 degrees is equal to opposite over hypotenuse. And you put the 1 there just to see, right? You're going to cross multiply and divide. So x is 2500 times sine of 12 divided by 1, which we're going to ignore. 2500 times sine of 12 is 519.78 because it's 779. If you follow on your calculator, you got to round correctly, okay? Rounding should be a thing of the past. You should be able to do that, okay? So that's the height of the hill. Next, an airplane climbs an airplane climbs at an angle of 11 degrees with the ground. If it's an angle, right, with the ground, it's angle of elevation. Okay, just so you know. Because you know that it's going to go, right, the airplane climbs, right, it's going up. So if this is the ground, the airplane is climbing. So you know that the triangle is going to look like that. Okay. Sorry, I'm going to start again. Find the ground distance it has traveled when it has attained an altitude of 400 feet. So imagine this is the ground, right, the runway, and at some point the airplane takes off like this, right, and makes a 11 degree with the ground, not 12. Okay, and at some point, right, it reaches an altitude of 400 feet. Right, it continues flying, but we're now saying, hey, right here it's 400 feet above the ground. Okay. Find the distances that it has traveled, the ground distance. So they want the horizontal distance it traveled. So they want this. That's your unknown there. So label, this is your angle, a reference angle. This would be the opposite side. Hypotenuse, I don't care about. Adjacent is here. So this is again a TOA example. Right? So tan of 11 degrees is going to be opposite over adjacent, like that. So this is where you have your x in the denominator. That's where the 1 is even more important because you're going to multiply here, divide there. So x is 400 times 1, which is just 400, divided by tan of 11 degrees. And that is 2,057.82, and we are in feet still, okay? And that's the first page. Sure you have that written down? And I hope you're following along. 400 divided by tan of 11. I get 2,057. Is yours set to degrees? Yeah. You're going 400 divided by tan of 11? Oh, I think you have to go. Yes. Yeah. 400 divided by 11 tan, yeah. Yeah, so if you have a different calculator, you might have to go 400 divided by, because as soon as you press divide, right, and it stays, the 400 stays there, you have to go 11 tan and then possibly hit equal again, right, to get this. So you have to kind of get used to your calculator. Backside, I'm going to do this a little faster here. A wire attached to the top of the pole reaches a stake in the ground 20 feet from the foot of the pole. So this is your pole. You have your ground. There's a wire. We call that a guy wire, right? And we know that this is 20 feet because this is a stake on the ground. And that this makes an angle of 58 degrees with the ground. Find the length of the wire. So they want this. So labeling would be opposite, hypotenuse, adjacent. So this is a cosine example, right? A and H, cosine of 58 is equal to adjacent over hypotenuse. You put the 1 here, you're going to have to multiply and then divide. So that's 20 divided by cosine of 58. These ones are trickier, so make sure you practice them with your using your calculator, because that's what you're bringing in for the test, right? 3774, and we are in feet still, so there you go, all imperial. So must have been an American person making this, a U.S. neighbor making this worksheet. Okay, Henry's flying a kite. The kite makes an angle of 43 with the ground. If Henry is standing 100 feet from the point on the ground directly above the kite, find the length of the kite string. So there's the string. This is where your kite is, right? And this will be the height. We know that the 43-degree angle goes there. Henry is standing 100 feet from the point on the ground directly below the kite. So this is the point directly below the kite. So Henry is 100 feet from that point, which is directly below the kite. So you have to just learn how to read these things. Find the length of the kite string. So that's your X there. Label again, opposite, don't care about it. Hypotenuse, adjacent. Another cosine example, right? Cosine of 43 is 100 over X. Just multiply, divide. I'm going a little faster here. So maybe if you're not able to catch up, just at least write down the right number. At this point, you can actually just do that right side by side. So that's the length of the string. I already did this yesterday. The angle. Unfortunately, this worksheet doesn't talk about angle of elevation or depression. But I'm pretty sure you know at this point what we're talking about. Okay, so let's finish 8 and 9 a little slower here. Okay. In order to reach the top of a hill, which is 250 feet high, one must travel 2,000 feet straight up a road which leads to the top. Find the number of degrees. It's kind of worded in a weird way, right? Number of degrees. It's just find the angle, basically. Find the angle which the road makes with the horizontal. The horizontal is the ground, right? You got to know that. In this case, it's the ground based on the context. So if this is your hill, right, like that, we know that there's a ground here. So to get up that to the top here, we travel on a road that's 2,000 feet. Okay, and we know that at the top of this hill, right? The height here is 250 feet, and this is your ground. And they're essentially asking, find the number of degrees, right? Find the angle between the road and the ground. So this is your unknown there. We're going to call that A. Okay, so you label based on this. This is the opposite. This will be a 90 here, right? So this is the hypotenuse. So opposite hypotenuse, that is so, right? So you go sine of, and you don't know what the angle is, so use a letter. And the opposite is 250 over 2000. This is an inverse example, okay? You're going to have to use the inverse. Let's go ahead and find out what 250 divided by 2000 is. And that's 0.125. It actually stops there. So angle A is going to be, since we started with sine, we determined this is a sine scenario. You got to take the inverse sine of that decimal. Right? So I basically have that on my screen. I go shift sine in this case, and you get 7.18 degrees. There is your answer. Last one. A lot, and you will, like, if I ask you to do these questions, do them, okay? Right now, this should just be like going over, making sure you got it right, or you need to make some corrections. A ladder leans against a building. The top of the ladder reaches a point on the building which is 18 feet above the ground. So we kind of have a pretty good idea what's happening here. Right? This is the ladder, of course. The top of the ladder reaches a point that's 18 feet above ground. So this is 18 feet here, right? The top reaches a point that's 18 feet above the ground. The foot of the ladder is 7 feet from the building. So this is 7 feet because this is the foot of the ladder. So we're measuring here. This is the building. You're 7 feet away here at the bottom of the ladder. Find the measure of the angle which the ladder makes with the level ground. So they want this one. We're going to call that A. Once you've done your diagram, right, you label opposite, hypotenuse, don't care about it, adjacent, okay? So this is a TOA situation. So tan of angle A is equal to opposite over adjacent. And let's see what that gives us. That's 2.5714. This actually keeps going, right? But then we say, hey, A is going to be tan inverse of 2.5714. And that is 68.75. Okay. Question. Could you figure out this angle here? Let's call that B up here. Could you figure this out? What does B measure? Well, angle B, by the way, this is angle, right? Some textbooks have that angle symbol in front of it. Angle B will be 180 minus the 90, right? There's always a 90 in our examples, minus angle A, right? So B is going to be 180 minus 90 minus 68.75. And that's 21.25 degrees. That's just an extension on that problem there. Some of you are asking, Mr. Dirksen, couldn't I use trig again to find angle B like the way we found angle A? Yes, you could. If you're up top here though, that's your reference and this is the opposite and that's the adjacent. So you got to be careful there. I would suggest just use the sum of 180 rule, right? Knowing that all angles always add up to 180 in a triangle. Okay, so now we're going to do the AC, okay? And I want you to stay online and I want you to submit it. I'm going to, at the end, go over it. We're going to go over it together, correct it, and then you'll submit it back to me so I can record what you got. This is what it looks like. It will be available to you in 5 seconds. Okay. Okay, so do AC now, okay? Go to classwork. To get it. Okay, so you can do that. If you have any issues, I'll be right here. I will do the attendance now, so get your keyboards ready as well. Where do I have that? Okay. I can't even do it. Right on it. Right on this one, sir? Yeah. Okay. Get your keyboards ready. Top, Gurjot Isabella Tyrell. Are you here? Perfect. All right. Gian, Patrick, Zandra. All right. Daniel, Reggie, Tessa, Montana. Christopher, John, Isabel, Yelena Jr., Lucas, Camden, Josiah, Francis, Benedict, Arabella, Carter, Raghav, Isaiah. Okay, I see you, Carter, yeah. Last group, Joshua, Mason, Ria, Ty, Luke. Okay, do the AC now. if you could raise your hand when you're done, that would help me out as well. Go ahead.